So welcome to the third episode of this webinar lecture. And just to give you a quick recap of what we've done for the past few weeks. So in our first episode, we had Prof. Epifanio Lopez, who discussed the various quantum leaps in land surveying techniques, and also the basic concepts in drone surveying. While in the second episode, we had Engineer Charisma Kayapan, who discussed the Philippine Active Geodetic Network, or PageNet, and its role in achieving high accuracy UAV mapping. So both speakers and in both webinars, the focus was on the importance of getting the accuracy right using drones. So for this one, we're thinking of switching the view, although it's the same, it's in the same sphere, but let's switch our gears a little bit. So apart from the other tools or softwares one uses to get the accuracy right, we think it's also important that the drone itself, meaning its physical components or hardware, are able to come together, work together to give you your desired output. So for today, we're going to talk about getting the specs of the drone right. And even more, let's talk about how you can build and customize your very own drone. Hindi ko na papatagalin pa, let me call Engineer Raylin Dialca, the Director for Project Administration of FEF, to introduce our speaker for today.
So our speaker today, if you remember, was also our previous speaker in Do's and Drones Season 2. He shared with us the experience of the UAS Practitioners Association of the Philippines in bringing drone registration and pilot certification to the provinces. He graduated with a BS Mechanical Engineering degree from the University of the Philippines in Diliman in 1974. He has been engaged in the construction and related industries for 40 years as design and construction manager. In the last 8 years, he focused on the unmanned aerial systems field as a service provider, systems assembler, and trainer under Radar Aero Resources, which he set up in 2015. He has provided UAS services to private companies engaged in mining and real estate development. He has also provided UAS image acquisition services to architectural and engineering design firms engaged in site development studies. As a systems assembler, he has provided complete UAS to various regional offices of the Department of Agriculture and some private companies. Philippine Council for Industry, Energy, and Emerging Technology Research and Development, or PCERD, under DOST, has also tapped his expertise to be a member of technical panels evaluating UAV-related project proposals and ongoing UAV projects. The De La Salle University has also commissioned him to train their DOST-funded UAV project team to assemble and operate fixed-wing UAVs. Currently, he is the president of the UAS Practitioners Association of the Philippines, or UPAP, a non-stock non-profit corporation which aims to promote the safe, responsible operation of UAVs, including compliance with CAAP UAV regulations. So for today, he is here to teach us on how to assemble our own fixed-wing drones. So let's go. Let's give him the floor. Let's give the floor to Engineer Jose Rene Montelibano. You can share your screen now, sir.
Thanks a lot, Rhea, for that exciting introduction. Well, good morning to everybody, and to all of you who are interested in drones. I'd like to share my experience in coming up with fixed-wing drones. As we note today, most of the popular kind of drones that are being used are what we call the multi-copter type, and specifically the DJI drones such as the Phantom 4 Pro, the Mavics, and the higher-end inspired drones. And all of these drones now are really quite mature in technology and are very stable in operation. But we old-timers, we started using drones by making our own drones, and these are the fixed-wing drones. So when we say fixed-wing, this really looks like a real airplane. So I'll share with you. This is not really teaching you how to make your drones, but this is just an orientation on what are the different components that make up a fixed wing drone. Okay, so the name of my talk is how to build and customize fixed wing drones. So if you see in this cover screen, these are the different types of fixed wing drones uh, that we are familiar with, and some of which we have built. So let's start. Okay, so the outline of my presentation is, first, I'll show you some of the applications that are where fixed wing drones are being used. Then the different components. So that's the frame or body, the propulsion system, the radio control system, the telemetry system and ground control station, the autopilot or the flight controller system, and then the mapping camera system. So for this example, I'll show you how to assemble a fixed wing drone which is being used for aerial mapping surveys. So the payload here is a mapping camera. Now, what are some of the applications? So for mapping, the end result is usually to produce orthomosaic maps. Orthomosaic maps, well, you cannot see, it's hard to see that contour lines here because they are in 1 meter elevation. The contours are 1 meter elevation. So in this slide, we show the result wherein the topo map is overlaid on the orthomosaic, and which in turn is overlaid on Google Earth, so that it will show how it relates with the environment, the mapped area, and what are the access points to that mapped area. This mapped area is actually a landfill in Calamba, Laguna. This video shows inspection and surveillance of coastal areas and some mapping areas. If you will note, most of these applications are also the ones where multi-copter drones are being used for. The only advantage of fixed-wing drones is that they can operate longer and cover larger areas. So here we see a mining concession in Palawan, which has been infiltrated with kaingin operations. So this one is an open pit mining, a nickel mining operations. This video shows the fish pen activities in Bolinao. Okay, now in this chart, we show here the comparison between the performance of different type of drones. So for the multi-copter drones, and the most popular ones are the Phantom series of DJI. We see here the area map per flight, average area, flight duration. Although the brochures say that they can operate for 30 minutes, actual operation is mostly up to about 25 minutes only. Then they can cover a distance of 7 with still good video coverage, and the maximum flying weight is about 1.4 kilograms. So here you can see the difference. For the simple type of fixed wing drones, like the example which we will show you today, the Skywalker 1880, the area map per flight can go up to 300 hectares depending on the elevation that you will operate it. Flight duration is about an hour, actually 45 minutes to 60 minutes, and it can go as far as 20 kilometers and still have good telemetry uh, coverage. The flying weight is a maximum of about 3 kilograms. For the newer type of fixed-wing drones with double motors and bigger batteries, they can cover from 300 to 600 hectares per flight, and a flight duration going up to 120 minutes or 2 hours. And with the new generation of telemetry equipment, they can go up to 40 kilometers. The flying weight is, well, a maximum usually of 6 kilograms, although, of course, there are larger drones than this. So what are for the first component, we have the drone or frame or body. So as I mentioned, the example here is a Skywalker 1880. The wingspan of this drone is 1.88 meters, and the body is made of a foam material. We call it EPO, which is quite durable. This looks like styrofoam, but this is very durable and resistant to solvents and higher density. So instead of explaining in detail the procedure of how to assemble this, you can just read about this when you get a copy of this PowerPoint presentation. Anyway, the different components are the wings, the fuselage, and the tail parts. So this is the elevator and the rudder, and then some wooden and plastic parts. So you assemble this using these assembly aids, cutting tools, tapes, adhesives, and for strengthening the bottom, which is usually subject to subject to landing on hard or rough surfaces, we put fiberglass with epoxy resin to strengthen the bottom. The most common adhesives that are being used are the contact cement types. And we can also use here the instant, what they call the instant glue. So these are the cyanoacrylate type of glues, of adhesives. The next major component is the propulsion system. And this is composed of the brushless electric motor. So these sizes are what we have used in assembling this type of drone. So these are actual sizes which have been tested and proven in operating this drone. So we have the electric brushless motor. Then we have the electronic speed controller, which adjusts the speed of the electric motor. And to power the electric motor, we use lithium polymer packs. In this case, this is a 5800 milliampere hour 4-cell lithium polymer pack. And this is the propeller that we are using. It's an 11-inch by 7-inch propeller. And these are the connectors which we use. Again, these are the detailed procedures on how to install the electric propulsion system. So you might need screwdrivers and soldering iron if you have to connect connectors to the speed controller. The next major component is the, wait, looks like I missed something. Okay. Okay. So the next major component is the radio control system. The radio control system is the system that is used to manually control the drone. Although in actual operation, when the drone is running its mapping flight, we don't use manual control anymore. But anyway, to start, for taking off and for landing the drone, we use manual control. And if there's an emergency, like if the autopilot suddenly malfunctions, we take over with manual control and we use the radio control system. So the operator of the drone uses the, well, in our parlance, we call this transmitter. This is handheld by the operator. Then inside the drone is the receiver, which gets the signal from the transmitter and transmits the signal into mechanical action through servos. The servos operate the different control surfaces. I will show that to you later on in an example. To power the receiver, we use a, well, we call this UBEC. This is what we call, BEC means battery elimination circuit. So from the main power battery, the BEC will regulate the voltage to 5 volts and feed this to the servo, to the receiver and the batteries. Again, here you can go over the detailed procedure on how to install this radio control system. The next important component is the telemetry and coupled with the ground control station. So while the drone is flying, the operator on the ground must be able to determine the flight parameters to be sure that the drone is operating as programmed. So the operator can see this flight parameter through the laptop on to which one of these modems is connected, and the other modem here is installed inside the drone and connected to the autopilot, and the autopilot feeds this modem the different flight parameters, and the drone installed modem then feeds this to the modem connected to the laptop, and on the monitor you can see, as shown here, you can see the different flight parameters. So you can determine whether the battery capacity is still okay. You can see the current consumption, the voltage of the battery, and you can determine whether the drone is following the flight path which you have programmed. If in case there is an emergency situation, um, you can then command the drone to return to launch through the handheld transmitter, and then you take over control of the manual control of the drone. So here again are the procedure on how to install the telemetry system. Okay, now the heart of the drone system is the autopilot, or the flight controller system. So the autopilot is the equipment which is the equipment where the programmed flight path is uploaded, and using this programmed flight plan, the autopilot controls the movement of the drone uh, vis-a-vis the GPS guidance. That is also, the GPS is also connected to the autopilot. So the autopilot used for this system is what we call the PICSOC flight controller. So the one shown here is actually not a very new system. This is one of the old reliable systems which we have been using for the past 4 years. And this is called the PICSOC 1. And coupled to that is the GPS. Now, in order to ensure that the flight speed is regulated and managed so that the drone will not go to a stall situation. Stall, which means that the flight speed is getting low, and because of that speed, the drone cannot maintain its lift, so it will start to dive. In order to manage the flight speed, we use an airspeed sensor, which is also connected to the flight controller. So here again are the detailed procedure on how to install this autopilot system. Now for the payload component, for this type of drone, we use a camera. So the camera is also connected to the autopilot through a shutter control cable. So, okay. So this cable connects the the camera to the autopilot, and the autopilot, based on the flight plan that has been programmed, will control the shutter operation. Normally, the shutter operation is based on GPS distance, so that at a given distance, the shutter will turn on and take the photo. And that GPS distance was established by the auto flight controller, by the autopilot, based on the image overlaps that you also program into the flight plan. So to achieve those overlaps, the shutter must be able to operate at a given GPS distance. And so here again are the detailed procedure on how to install the mapping camera system. So the mapping camera is just one of the payloads that can be used in the fixed wing drone. In this case, it's a mapping camera because the use of this drone is for aerial image acquisition used to produce maps after being processed. There are other types of payload, such as a video camera with a video transmitter for a surveillance type of drone. And as what we have shown in the previous video, but we did not include that in this presentation because the purpose for this presentation was to present a mapping drone. However, we can show you. Oh, no, let's do that later after we finish this PowerPoint. So that's a very brief orientation on what are the different components that goes into assembling a fixed wing drone. However, for those interested in really going into operating fixed wing drones, we also offer a training course which includes assembly of fixed wing drones and operation of fixed wing drones and maintenance. So for those interested, you can get in touch with me through the contact details at the end of this presentation. Okay, this is another type of fixed wing drone. So this does not carry a mapping camera, but it carries a, well, also a camera, but this camera is just taking videos of the areas where the drone is flying over. So this camera can be controlled in terms of panning left or right, or panning down or up. And aside from the camera, the drone must have a video transmitter, and this is the antenna of the video transmitter. So the video transmitter is located at the bottom of the wings. So the video or still photos which this camera takes is transmitted to the ground via the video transmitter, and on the ground you also have a video receiver attached to a monitor which shows the footage taken by the camera. Aside from real-time viewing of the footage, it's also possible to record the videos through a digital video recorder attached to the video receiver. So now that video camera can be shown here. Okay, so we usually call this type of drone operation as a FPV, or a first person view, because what the operator will be seeing in the monitor on the ground is what the camera is looking at. So this is very similar to what you see when you operate a DJI multicopter. The only disadvantage of this drone in that kind of operation is that it cannot hover. So you cannot stop the drone from flying. It just goes on and on. But the advantage is that it can cover a, a longer distance. This type of plane, the actual performance of this type of plane in other countries is that it has been able to reach 200 kilometers distance. So that's a lot of distance you can cover. Ito yung autopilot. This is colored blue. So
Mm.
there are a lot of wires here actually, no. So that is what is more important to learn. And then ito yung radio receiver. So this is the equipment that gets the signal coming from the handheld transmitter. Okay, and here we have the GPS. This one. This gadget houses the GPS and the compass. So that compass should be calibrated before first time you fly. And here, oops, ito, ito yung airspeed sensor. Airspeed sensor. Yan. And this is the battery compartment. Ito yung lithium polymer battery. And here, you will see the compartment of the camera. Well, you cannot see the camera because it's inside an enclosure. This is a fiberglass enclosure. So, and so that camera, this is where, when you operate the camera, the lens will zoom out, and so you have a hole here at the bottom. Okay. Next, this is the electric motor. Well, hindi ko lang nalagay yung prop kasi istorbo sa movements. And this electric motor is connected via these cables to the electronic speed controller, which is inside here. And then, well, this is the servo which controls the rudder. This is the rudder. So it moves the rudder based on the signal coming from the autopilot or from the receiver. And on top, well, medyo ang screen natin ay medyo maliit. So here, we bolt on this, we call this the horizontal stabilizer, and the moving part is the elevator. That one. And that is controlled by this servo here. Okay. Now, these are the wings. So you have to connect them and attach them to the top of the fuselage. But what is important here are this is the aileron. So this controls the rolling motion of the drone. And these are the servos which operate the ailerons. Okay. So these are the wings are actually assembled. There's a carbon tube that goes inside here and connects the two parts of the wing. Uh, on the other wing, we installed here, this is the telemetry modem, which is connected to which is installed in the airplane, in the fixed wing drone. The other modem is down on the ground and connected to the laptop, which serves as the ground control station, but we don't have it here. Okay, so I hope that makes it clearer on what a fixed wing drone is.
Okay, thank you, Sir
Okay.
Jore. I'll open now the floor for questions. So we have a first question here from, oh, hello, Prof. P. He's also attending pala. But our first question would be from Sir Jose Junior Gavino. Good morning, sir. How are you going to secure a controller certificate drone pilot for a fixed wing? Since we all know that the CAP requires us to perform actual flight operations with required maneuvers in order to pass the skills test. Thank you.
What was the question again?
Sir, how are you going to secure a controller certificate daw for drone pilot for a fixed wing?
Okay, now this is the nice thing about getting the CAAP controller certificate. When you get that controller certificate, it does not signify whether that certificate is for a fixed wing drone or for a multi-copter type of drone. So what CAAP is giving out now is a general form of certificate which does not indicate what type of drone you are operating. So when I took my controller certificate, when did I take that? I take 2015. Um, when I underwent the skills test, which is actual flying of a drone, CAAP tested me uh, flying a DJI Phantom 3. So after I passed the test, I got the certificate, and that certificate is good, uh, even if you're operating a fixed wing drone. Now, the only time that CAAP will want to know what drone you are operating is when you register the drone. So,
Mhm.
first you get the controller certificate, then you register your drone. In registering the drone, it is of course you register what type of drone you want to register. So if you want to register your fixed wing drone, you bring your fixed wing drone to CAAP, and they will evaluate it, and then it gets registered. So if you want to register a multi-copter type of drone, that's what you bring to CAAP for them to investigate. So to answer your question, getting a controller certificate, whether you're operating a multi-copter type of drone or a fixed wing drone, is just the same. But you know, the important thing to to know here is that, or the most important thing to look out for is that you must be able to pass the skills test of CAAP. And so you must tell Kaap that is Kaap here in the is Kaap
Sir,
present
sir,
here?
parang wala po kaming
Well, anyway,
nakitang wala naman.
totoo naman,
But probably they're watching Facebook.
totoo naman to sinasabi ko eh. So maybe this can be an input to what they plan to do in the future. So what is important to note is that you must be able to pass that skills test. So you must bring the easiest drone to fly when you take the skills test. And what's the easiest drone to fly? For me, it's the DJI
Quadcopter.
Phantom series. So I brought a DJI Phantom 3. And so I easily passed the skills test. So please note, I think may point naman si Mr. Who was the one who asked the question? Gavino, no?
Mr. Gavino, yes, sir.
Yeah. I think Mr. Gavino has a very good point. You know, CAP should really test you on the type of drone you're gonna fly. You will be operating. So I think there should be a test for fixed wing and a test for multicopters. Pero maraming magagalit sa akin yan na drone operator if I post that with CAP. Anyway, that's how it is now.
Mm-hmm.
Okay.
Okay, thank you, sir. Sir, to that sa topic na yon. Questions from Sir J. Lord Morales. He asked, kapag na-assemble po ba yung drone, kailangan iparehistro sa CAAP? And second, kailangan po ba ng sariling drone para maging certified CAAP controller? So, doon muna tayo siguro sa first
Let me
question.
answer first the second question.
Okay,
Do you
sir.
need to have your own drone to be registered as a controller, as a controller? I don't think so, because when you go to CAAP and operate your drone during the skills test, hindi naman nila tinatanong kung sa iyo ba yung drone na yan o hindi. Ang importante dito ay marunong ka mag-operate ng drone. Katulad ng kotse, hindi ba? Pag kumuha ka ng lisensya mo, it is not necessary na may sarili kang kotse. Pero tinitest ka muna kung marunong ka mag-drive ng sasakyan. So ganon. So the answer is you don't need to have your own drone to be registered as a controller with CAAP.
Sir Jory, dun sa skills test, you need to bring your own drone, di ba?
Yes, you have to bring your own drone, but it does not have to be your own. You can borrow it, you can rent it, or whatever.
Sir, akala nila, drone ng CAAP ang ipa-fly nila.
Hindi. May drone si CAAP, pero hindi nila ipapalipad yan sa iyo.
Baka mabagsak mo. Patay.
Risky, pwedeng bumagsak yun.
Okay.
Okay.
Ayun po. Yung first question niya po is, kapag na-assemble na po yung drone, need po ba yan iparehistro sa CAAP?
Well, kung gagamitin mo to for commercial purposes, the CAAP Memorandum of Circular 2915 issued in December of so and so. Anyway, if you will use this for commercial purposes, you're supposed to register that with the CAAP, but after you have registered as a controller. So, ang number one, mag-controller certificate ka muna, and then register mo sa CAAP.
Okay. Sige po. Sir Volts, do you want to add anything to that?
Yeah, sir. Ayun pala. Tanong ko, sir, usually magkano yung cost?
Na itong drone.
Yeah, kahit without the payload muna, kahit nayaan lang.
Ano yan?
Huwag niyo muna po isama siguro yung
camera.
Without the payload.
Walang payload. So that means walang camera, no?
Yeah,
okay. For the specific drone which I presented to you, actually, Volts, gumagawa ako ng bagong costing nito kasi alam mo, mabilis mag-change ng mga presyo, no? So, I cannot really give you an exact one, but I can give that later as soon as I finish my estimate kasi nagka-canvas ako. But maybe as parang sa experience ko noon, without a camera, this will cost siguro mga 50,000. But again, that is based on the equipment na pinakita ko dyan. As you know, ang bilis ng upgrading ng technology ng equipment. So like yung autopilot kanina na pinakita ko sa PowerPoint, yung PICSOC, marami ng bago especially yung nakalagay dito ngayon sa pinakita ko yung actual na drone na mas compact at mas mura at mas maraming features. So baka pwedeng bumaba ang presyo niyan. from 50,000, pwedeng bumaba. So I'm completing that now because I'm just anticipating that if there will be people who will get in touch with me asking about that, magkano to, I can give a more exact answer. So anyway, for those interested, just get in touch with me through email or my cell phone. You can find that at the end of the PowerPoint.
Sir, in addition lang with that question, ano po yung mga advantages of assembling or making your own drone compared to buying a commercial drone?
A commercial, a fixed wing drone din, a commercial?
Yes pa.
Well, malaki ang diferensya sa presyo. Talagang mura. Baka kalahati.
Aside from the presyo, sir.
Well, for those who are technologically inclined, masarap eh. Masarap na, alam mo, yung creation mo, tapos biglang makita mo lumilipad na, kumukuha na ng pictures. Ang sarap ng feeling nun. So sa akin, yun talaga ang number one motivation ko. Yung the satisfaction of being able to realize certain technological advancements na nababasa mo lang, pero ngayon nakikita mong nangyayari talaga dahil ginawa mo. So, but again, ang advantage of making your own drone, actually, no, when you say drones, ang talagang naiisip natin kaagad ay yung mga multicopters eh.
Yes.
Mga DJI drones. Saludo rin talaga ako diyan sa mga multicopter drones kasi ang technology nila talagang advanced na. Mature. So very reliable na. Pero ang medyo disadvantage lang nila, especially yung mga Phantom series, limited ang area coverage at saka ang duration na pwede mo i-operate. Although, kung marami ka namang batteries at saka gamitin mo yung katulad nung ginagamit ko na flight planning app, yung map pilot for DJI, wherein maski 200 hectares yan, let's say if you have 16 batteries, kaya mong tapusin yan. Although not in one day. Kasi palit ka ng palit ng battery dyan eh. Pero reliable talaga ang operation nitong mga DJI drones. So when I mean reliable, it is sure to come back to you. Ibig sabihin at safe din. So smart nga eh. They call it smart drones or smart battery because it can determine that if the battery is just enough capacity to go back home, it will automatically return to launch. So for me, sa mga mapping operations ko na kung maliit lang yung area, kasi bihira naman makakuha ng malaking area eh. So let's say mga 50 hectares, I can I use the DJI Phantom 4 Pro, and for that I would use about 3 batteries. So ang importante lang dito, marami kang battery. Kaya lang mahal din yung battery. So anyway, maraming trade-offs eh. So depende na talaga sa diskarte mo yan kung saan ka komportable.
Sir, how about yung in terms of yung mga repairs and of the fixed wing drone?
Well, ang fixed wing drones kasi alam mo, hindi ba yung operation niya, hindi siya maka-vertical take-off and landing. Although there are fixed-wing drones now na pwedeng gumawa ng ganon, but medyo ang technology ay medyo medyo mahirap bago. So, in terms of repairs, ang fixed-wing drones, most of the how would you call it, yung situation wherein you need to repair it is if you get a bad landing, let's say hindi mo siya limited yung area na pwede mo paglandan, pipilitin mo siya magland and in the process makakrash siya. So but usually ang masisira lang naman diyan yung katawan. Ang maganda sa itong material, yung foam material niya, this is like a cushion eh. So it will save the equipment inside the drone. So ang masisira lang dito yung foam.
Outside.
yung labas lang, yung magka-crack siya o pwede ring maputol, pero you can easily repair those. Madaling i-repair. So, but again, in cases of how frequent do you need to repair it, mas frequent ang repair sa mga fixed wing drone. Especially kung nagsisimula ka pa lang. Kaya ang importante, pag nag-operate ka ng fixed wing drone, you really need to learn how to control it manually. Kasi doon papasok ang how do you land it? So you land it manually, manual control, hindi automatic. Sa mga multicopters kasi automatic na lahat yan pati landing. So,
Okay. Thank you, sir. Okay, we have questions here from Prof. Ping Lopez. Yung first question niya po is there a possibility that your training workshop modules can be incorporated in TESDA programs? And yung second question niya po is, are there vendors of fixed-wing drones who are aware of your program? Has there been reaction from them?
Yung mga so number one, yung kung pwede i-include sa TESDA.
Pasok sa TESDA, yes, sir.
Well, of course, it's possible, but how do you go about it? Well, like me, happy naman ako na maski konti lang dyan ang natuturuan ko. So, wala naman sa akin motivation na kailangan ko i-include to sa TESDA program. But who knows? You can never say kung ano yung later on. Number two, regarding vendors. Well, definitely,
yes, sir.
they don't get threatened from my program. Kasi limited naman yung market talaga nito yung interesado dito sa fixed wing drone. Kasi for one thing, mas mahirap sa i-operate at saka mas marami kang kailangan matuto dito. So, limited lang ang market talaga nito.
Okay, sir.
So far.
So, go.
Wala si Ann.
Okay, sir, in relation to that, may nagtanong po dito, do you sell commercially your assembled drones?
Yeah, I sell this like what was like as what Ria said earlier, that well, I've sold to Region 4B of Department of Agriculture and to Region 3. So yeah, I do sell, and then I've sold to some private organizations.
Okay, sir. May tanong po dito yung kasama namin si Attorney George Katigbak. Sir, locally sourced daw po ba yung parts or imported?
The source are all imported. So nobody makes it locally. But there are importers who might carry some of these parts. But for me, I really source this. I look at a lot of online stores. I look at or I read a lot of forums to find out which components are reliable, because there are really a lot of suppliers of these components, not locally, abroad. So it might be risky to just get from any source just because it's cheaper. So you must have a basis for determining which components you want to use. So I'm a member of a lot of these forums dealing with drones, and that's where I establish what components are reliable. Then I order it online. It's now very easy to order online. It's a bit harder now because ang shipping medyo nagka-problema because of the pandemic. So before, we have the Philippine Postal EMS service, which is very efficient. And so you can get almost anywhere in the world, and it will arrive here in a week's time. And all you have to do is order online and pay with your credit card or pay with PayPal. And darating yon. So, but ngayon, nahinto yung EMS ng Philippine Postal Corporation. And so, you depend on FedEx and DHL na ang shipping costs ay more than double. Yun pa ang isang palang problema. Kaya tumaas ang
Okay, sir.
presyo.
Okay. Sir, may addition po dito from Mr. Gavino. Sir Jore, FYI lang, CAAP now has a plan of giving one license per specific drone per person. Kaya tama daw po kayo na dapat ang CAAP meron din na way para ma-check ang skill sa fixed wing ng drone. Thanks po.
Ay,
It's
mabuti yan. Para mas kukonti ang competition. Kasi mas mahirap yan yung fixed wing drone. Anyway, but that's good. That's what I was really, actually, during our meetings with CAAP in previous years, we were trying to clarify that and trying to tell them that dapat may test talaga for specific drones.
Yes,
So
sir.
that's good. Is Mr. Gavino connected sa CAAP?
Maybe we can call on him so that
Kasi
sige, sir.
I regularly
hanapin ko
get in
siya.
touch with CAAP also, especially with the licensing division, because I follow up some controller certificate which yung inano kong sa Cebu, yung the one I facilitated in Cebu. But the problem now with CAAP is if you're a senior citizen, you cannot go there. So tawag na lang. And sometimes pag tinawagan mo, may itatanong ka sa CAAP, sabihin nila I'll get back to you, but usually you have to call them up again so that they get back to you.
Sir, andito na si Sir Jose Gavino.
Yeah. Hello, Mr. Gavino.
Ano kaya?
Yan.
Mr. Gavino.
Sir, pa-unmute na lang po. Ayun. Okay.
Mr. Gavino, good morning.
Good morning, sir.
Hi. Regarding yung information that CAAP will now be giving tests on specific drones when you get your controller certificate, is that right?
Hindi pa, sir. Nag-formulate pa lang sila kasi inaantay nila sa yung sa ICAO, yung International Certification.
That's right. That's what they told us 2 years ago pa yan. Sinasabi nila na hinintay nila si ICAO. ICAO. But I really welcome that news. Kasi in order to be giving out certificates and making sure that the controller who will use it will be using it safely talaga. So CAAP must know what drone they will be operating. Kasi there's a lot of difference in how you operate fixed-wing drones and multicopters. And the safety considerations for fixed-wing drones is a lot more, anong tawag niyan? There's a lot more to be concerned about safety when you operate fixed-wing drones. So that must really be tested by CAAP.
Okay.
But it's good to note also, I'm using the open source AUTOPILOT firmware sa fixed-wing drones ko. At saka dito, napakabilis na mga updating nito. So dati, when you take off with your drone, you have to turn on sa transmitter mo, turn on the motor, then you throw it, Then when you throw it, hindi mo pa sigurado kung bababa siya o tataas siya o kuminsan habulin mo sa transmitter yung pag-stabilize ng drone. But now with the new features, they have this auto takeoff feature wherein you program yung parameters like how much should it go up, dapat level siya pag take off. So napakadali na and quite safe na rin ang operation. And so those are the factors that CAAP should be testing the fixed-wing drones if they have these new safety features.
Okay. Sir, I'll entertain 2 more questions. Ito from Sir Gavino din. Sir, may discuss niyo daw po ba yung specs ng launcher?
Kailangan
Or
Anong launcher?
include.
What launcher? Can you clarify?
Usually, sir, di ba may launcher yung mga mga picture?
Well, dati kailangan mo ng launcher. Pero ngayon, dahil nga doon sa mga new features of the flight controller software, I don't think it's necessary. Although, there are some drones pala na practical may launcher, like the one we tested in Magalang, Pampanga. The one which is yung parang wing lang siya, di ba?
Easy map ba yan? Tama ba? Yung map drone?
Yeah, I think so. So, ang problema kasi nung ganong klaseng drone, mahirap hawakan at saka i-launch manually. At saka, yung fixed wing drone, at saka ang problema ng ibang drones, mabagal bago siya maka-reach ng take-off speed at which it will be stable. Pag simula pa lang, pag pa-under mo ng motor, kailangan mo ng kasi it will take time bago it can reach good take-off speed para stable siya. So maybe kailangan mo ng launcher. But the type of drones I'm operating, I don't use launchers. I don't, yung parang catapult launcher.
Yes. Okay.
So, I don't know if that clarifies Mr. Gavino's concern.
Okay na ba, Sir June?
Anong launcher ba yung you're interested in? Or anong type of drone ang gusto nyo i-operate?
Sir, nagtatanong lang ako, sir, kasi akala ko niyan, hindi yung tinutro mo lang tinatapon. Akala ko may runway talaga siya, may launcher.
May launcher? Wala na. Hindi na kailangan ng launcher. At saka bulky pa yung launcher Kung...
Sir. Ayun lang naman po.
Thank you. Thank you, Sir June.
Thank you.
And finally, last question po. Sir, I think na-answer niyo na po ito, but just to reiterate, sir, ano po yung mga problems or errors na encounter niyo sa system? When probably, I think this means when you're making or building your own fixed-wing drone?
Yeah.
During the building, sa building part, during building, wala naman ako na-encounter na problema, but siguro, okay. Dito kasi, what we just talked about is assembling, no? So, hindi pa natin napag-usapan how do you activate the different systems. So, when you activate the system, there are certain procedures you have to follow. Now, if you miss some of the steps during activating the system, you will have a problem. So, ang importante lang naman dyan, reviewin nyo palagi ang system and procedures of how to activate the system. Like, if you're using the software that I am using here, so there are two types of system. You have the flight planning and monitoring system, which we call the mission planner. So, nagbigay ako ng link doon sa relevant portion ng PowerPoint presentation. So, in operating that system, may mga definite steps you have to take. So, dapat you have to read the documentation on that system, the mission planner software. Then you have also the firmware which controls the drone. So this is the one which you upload to the flight controller or the autopilot. And this is the Arduplane firmware. So may documentation din yan. Nandun din sa link na linagay ko sa PowerPoint. So all you really have to do is really to read it and understand.
Mm-hmm. Sir,
yes.
Na lang siguro na question from me is with regards to the type of basic skills na kailangan meron yung gustong mag-assemble ng drone.
Okay, so mostly kasi hindi ba foam to, sa body foam, so it's just a matter of gluing together, so no special skills. Pagdating sa electronic part o pagdating doon sa electronic part, I think you must have some basic background on electrical, paano ba yan? Yung mga relation between voltage, current, and wala nang resistance. Like relationship between voltage and current and amperes. And if you have to, usually kasi plug and play naman tong components but there might be instances wherein you have to solder some connectors into itong mga gadgets, so you must know how to do soldering skills.
May programming skills po ba?
Very simple ang programming dito, menu driven yung you have to program something pero menu driven, so tinatanong ka, will you choose this or that, ganon lang klase na programming
na siya. Okay po. Yun po.
Okay, thank you, Sir Jory, and I'm now officially closing the Q&A. Just want to remind everyone that there's a feedback form. You can check them out here. I'm sending it now. Also, we'll be providing the certificates of attendance of this webinar by next week, and also the presentation of Sir Jory. If you have other questions, drop us a message on our Facebook page. And this webinar, an edited version, will be uploaded in the FB page as also in the FEF's YouTube channel. And finally, we hope you guys join the Pista ng Mapa 2020 that will be held next month, 3 consecutive Fridays of November. You can find them in Facebook as well, Pista ng Mapa. And I would like to thank our speaker, Sir Jory, for joining us again.
Thank you.
For the second time. And also our partner, the Asia Foundation, and also to all of you participants for joining us today's webinar. Thank you very much. Good noon. Malapit na mag-good noon, and please do stay safe and healthy. Maraming salamat po. Bye-bye.
Bye.
Thank you, Sir Jorge, as always.
You're welcome. Very welcome.